The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I'm going to talk about the history, background of how 562 came about, and then I'm going to give some teasers about what the other speakers are going to talk about regarding various major sections of the 562 code. Remember, this is called Code Requirements for Evaluation, Repair, and Rehabilitation of Concrete Buildings. The scope is for building structures. And some very key points that I want you to keep in mind all afternoon. The code was developed to provide consistent minimum level of life safety and performance of repaired buildings. And the life safety is the key to development of any standard within ACI and why we are proposing this be adopted by the International Existing Building Code. A very different feature of this code is that it is performance-based. Unlike ACI 318, for which everybody is familiar, 318 is a very detailed code. It's not a performance space. It's a specified code of how to do things specifically, whereas we set goals for performance of a repaired structure. It is designed to help design professionals and building officials by providing a uniform standard of design and construction. It is undergoing continuing development and improvement, and so I want to comment for everybody here is we in 562 are looking for comments, suggestions for improvements, how the code has performed for you in a design situation, how it is lacking and needs specific improvements, and anybody on the code committee will accept your recommendations, and they will all be considered as we continue to develop the 562 document. Well, why a repair code, and first of all, how it came about? Well, it really started with a joint meeting called Vision 2020 as an ACI strategic development. And in this development, this Vision 2020, there were a couple of meetings in 2004 and 2005. It was attended by ACI Strategic Development Council, executives and members of ACI, but also members of ICRI, a real great partner with us, along with consulting engineers, building officials, owners of structures, government authorities. So it was a big meeting in which there was a lot of visioning about where repair rehabilitation industry was going. And one of the primary results of that meeting was the development of a need for a repair code. And that repair code was designed or was suggested to establish evaluation design, materials and construction practices, that is a minimum level to raise the level of repair and protection performance. This would establish, the code was designed to establish clear responsibilities. And what Vision 2020 wanted was responsibilities for owners, contractors, designers. What 562 does, though, is really look at what the design repair engineer needs to do. So 562 is really oriented towards the designer. But in oriented towards the designer, we give the designer specific responsibilities to convey information to the constructor, as well as reports that are to be provided to the owners of specific buildings. It also is there to provide building officials with the means to issue permits. Currently, code officials like Gus Arakas from New York, who will be speaking in a few moments, really had needed to go back and specifically look at individual buildings and be really knowledgeable on repair as well as new construction. Many building authorities don't have such experienced building officials, and they really lacked an ability to decide how repair is done compared to how new structures are created. So a goal of this code was to level that and give building officials a great means to issue permits for rehabilitation of structures. Again, why the repair code? Well, a large segment of the construction industry is for repair and rehabilitation. It's about a $20 billion a year industry, $8 billion just due to corrosion damage by itself. Specifically, though, repair performance has been noted as poor. That is, the Corps of Engineers, about a decade ago, did a survey and found that 50% of repairs were not performing satisfactorily. As an example, after 10 years, only 30% of the repairs were satisfactory. That is, 70% of the repairs were failing. This is a miserable performance, and the goal of the code is to raise that performance. ACI 318, also about a decade ago, conducted a survey and found that about 1/2 of the use of the 318 code was for repair of existing structures, even though that document is specific for new design. And they found a lot of it was for use of non-building structures. The conclusions from the ACI 318 survey were that the ACI 318 document was functioning beyond its original intent, and that code guidance for repairs was needed. And this is even though there is a Chapter 20 evaluation of structures within the 318 document. Furthermore, repair construction showed a dramatic variation in performance. Performance of the repairs, but also in practice. That is, some contractors gave very, very low bids, said they could do the job. Those repairs did not perform satisfactorily, but they were not required to do any more than what they said they were doing. Whereas other contractors used high-quality methods, many of them represented here in ACI committees, quality jobs, but they cost more. And in that case, poor contracting kind of put the more qualified people out of business. They didn't got the job. The poor contractors, low costs, did. And in doing that, repair became poor. We got poor performance. We want to raise this level of performance. Well, those were reasons for having a repair code. But there were several groups that did not want a repair code, and there's various reasons for not wanting it. Number one is a rigorous process. There actually are quite few ACI standards, that is, things that go through the Technical Activities Committee Manual, Chapter 5. It's a long process, a very detailed process. Our code only took 7 years to develop, and that was regarded as extremely fast for developing a standard. There was questions about could we have a consensus, because all of these documents are consensus documents under ANSI requirements and ACI requirements, and is there a consensus for minimum standards for rehabilitation? It was questions whether we could establish minimum practice requirements. Now, most of you are on ACI committees, and notice that actually you can develop minimum standards because you're the experts in your specific areas. You can agree and reach a consensus on it, and that really does establish minimum requirements. My personal concern was a concern about limiting creative solutions. In repair design, also in evaluation and repair construction, it takes a lot of creative solutions. As you're going through a building, you uncover specific deficiencies that are not covered anywhere in any textbook or any building code like 318 of how to solve it. It takes some real innovation. And one thing we did not want the code to do was to diminish that innovation and creative process of engineers in satisfying owners and in correcting deficiencies. So how are we going to do that? Well, from an ACI Technical Activities Committee standpoint, most documents are created by individuals and other committees saying, well, we need this new things done, and it's a bottom-up process. For this code, it was a top-down process. That is, the Strategic Development Council, as part of Vision 2020, actually said we really need a code, told the Technical Activities Committee that we needed a code, and TAC then decided how such a code committee would be formed. So it was truly a strategic development of ACI. Well, you can think, well, repair has been around ACI for a long time, and it certainly has been. If we look even in the 318 code, Chapter 20 first came into existence in the 1971 code, right? So over 4 decades ago. Committee 546, which just had several sessions. The Repair Committee had been in existence since 1969. The ACI 364 Rehabilitation was first created in 1981 to kind of help oversee rehabilitation activities within ACI. Committee 437 Evaluation has been in existence since 1958. So that's a long-term committee. And then finally, the newest one, ACI 369 Seismic Rehabilitation, has been in existence since 1991. So that's the new one. But even the new one is 2 decades old. So we have been talking about evaluation, repair, rehabilitation within ACI a long, long time. And even with all of that, the ICRI was created a little over 10 years ago in order to emphasize construction and quality construction within the repair industry. So we have over 23 committees also identified by the Technical Activities Committee on Repair and Rehabilitation that are actively doing work on evaluation, repair, and rehabilitation. So throughout ACI, there's a lot of talent and a lot of information from which 562 could gather information and refer users of 562 to all of those technical documents. Well, the code development process. Well, once we started, the committee was organized. We had to follow ANSI developed consensus guidelines. Those guidelines are elaborated in our ACI's Technical Activities Manual. It's actually Chapter 5, Section 5 in that manual, which gives all kind of detailed procedures. As I said previously, the 562 is written for design professionals. We call them licensed design professionals as a term of art, but it's really primarily towards engineers that are doing repair design, evaluation, and supervising construction. It really only becomes a legal document when it's adopted into law by a general building code. So in the United States, that might be the International Building Code, and specifically the International Existing Building Code. Well, what's happening with IBC and IEBC that are important to what's happening in 562 and ACI? Well, within this current cycle leading to the 2015 IBC, the IBC board has approved the Chapter 34 on existing structures is just going to reference the IEBC. So the details in Chapter 34 are going away, and all those details switch over to the International Existing Building Code. The 2015 IBC is adopted by many states and many jurisdictions in the United States, but not all. In this process, the IEBC for 2015 did not adopt the 562 code, but the 562 code is still establishing the state of practice or the state of the art for repair of concrete buildings. Creating the repair code. Well, the first thing that the committee did was establish a philosophy of what this code was going to be. It was to emphasize performance-based rather than prescriptive requirements. This is a major deviation from a lot of codes within ACI. And it particularly needed what performance was needed, but then how that performance was going to be measured. It was to encourage creativity and flexibility. So as you're using it, many people want to see, do it this way. You will not see that. You're going to see we want a certain performance out of it, certain considerations you have to give, certain measurements you have to meet, but no specific way on how to do it. It's to promote innovation in new materials. It establishes responsibility and basically instructs the engineer of what you probably need to put into specifications for constructors. The goal, again, was to enhance life safety, as well as to extend service life of an existing structure. We believe in 562, and I know 546 people, anybody in repair here, believes the most sustainable thing anyone can do with concrete structures is to sustain existing structures, to repair and maintain them. And in that way, we don't need to make a lot of more new cement, right? We don't need to find out what to do with demolished materials. We're using the structure, so it is the most sustainable activity. The other goal in 562 was to reference ACI standards and other documents. What that means is, rather than writing everything in-house ourselves, we reference other guides. We reference guides in our commentary, but we reference other standards as part of the code. So for like load testing, we don't write how to do a load test. We reference ACI 437, the evaluation document, and say use that standard of how to do it. And this is what we are looking for in continuing development of the code, is to reference other ACI standards. So if your committees are writing standards, we want to know about it. Key steps in rehabilitation and the continued use of existing buildings. As a process, is to determine applicable standards and general design requirements. We then think there's a preliminary evaluation which establishes whether there is substantial structural damage. That's going to determine if a building is unsafe or not, and sets a path whether you're going to original building code documents or current building code documents. You perform an overall evaluation, conduct repair, rehabilitation design, and through that design you also have considerations for durability and for planned maintenance. And maintenance becomes a really novel thing here that you'll hear about for the 562 code. We want construction done in a specific way so that we can look at how the structure is performing during that construction process, as well as quality assurance procedures. Now, as a tease for what other people are going to present, Gene Stevens, sitting in the front row, is going to talk about what the code is, what it does. He's going to look at the standard which requires safety and serviceability. The code governs superstructures, foundations, basically anything that's in a structural load path. Structural versus non-structural, this becomes a real question. If any piece of the building is unsafe, it's covered by this code. It establishes a design basis code, what the general building code is, sets evaluation, repair, design, durability requirements. Chuck Larosche, also sitting in the front row, is going to talk about evaluation processes, extensive damage, assessments, load test, and specifically looking at as measured dimensions, measured or historic properties. And after questioning that, these are questions to think about when Chuck is up here to ask him detailed questions. Rick Adelson will later speak about repair materials. Notice this code is allowing fiber reinforced polymer as a structural material. It's including not only steel reinforcement, but steel without cover, that is external exposed reinforcement. This means we have to really consider fire, elevated temperatures, and other conditions which are going to affect that exposed reinforcement. We also have to define repair sequences so we don't collapse the structure during the repair process. So Rick is going to talk about those kind of items. Fred Goodwin will discuss durability. The whole concept of service life, even though that's not going to be defined, it is how do we extend use of the structure. Corrosion protection, cover, and corrosion deterioration, and what you do with corroded reinforcement. Finally, construction and specifications. Jay Paul will talk about some of that. including specific requirements regarding shoring, loads during construction, and how we provide instructions to the contractor. A lot of this falls down to Committee 563, who right now are developing specifications for evaluation, repair, and rehabilitation. So when 563 comes out with their documents on specs, you'll really want to hear that. So future directions: continuous improvement of our code, adoption of our code by the International Existing Building Code, and particularly adoption of our code in design practice. So we hope all of you get copies of the code, see how it's going to work in your practice. Education is going to be a big thing. We're developing, along with ICRI, guide to use of 562, like some of you are familiar with in 318, the guide or the notes for use of 318 by the PCA. We'll have very nice examples on how to use this code, and again, a focus on sustainability, that is reuse of existing structures. Acknowledgement: there's the code committee. These are the people that did all the work. You see many of them around the session in Reno. 15 engineers, 4 academics, 3 contractors, material suppliers, owners, and building officials. So we had a committee that was diverse and had a lot of expert opinions. Thank you.
Thank you very much.